The bitterness of poor logging remains long after the sweetness of fast code is forgotten. But logging isn't just about writing logs. It's about writing the right logs so you can spend less time debugging. Imagine you are a detective at a crime scene. Do you just grab random objects and hope they tell you who the criminal is? No, you collect evidence strategically. So before you write a single log, you need to answer these three questions. What are the primary user actions? What system events are critical? And what metrics or measurements can I log to track feature performance over time? Your main goal is to write logs that will tell your future self a clear story so he can find the issue fast. If you log blindly, you're just creating log noise, making it impossible to find the issue. How many times have you seen an error message like this? That's about as helpful as a fortune cookie that just says something will happen. But your goal isn't just to catch a problem. Your goal is to provide enough information so you can replicate and fix the problem. But speaking of information, not all logs are created equal. That's why we use log levels to categorize logs based on importance. There are 5 main log levels. First, we have info. These are general system events. This level doesn't indicate a problem, but rather expected behavior. Things like user successfully logged in, subscription renewed for user, and received API requests. Then we have the debug level. Consider this a behind-the-scene level. It contains detailed context useful for troubleshooting, helping developers follow the execution path step by step. But it should not be enabled in production. Some examples are starting scheduled jobs, user navigated to cart page, or memory usage statistics. Then we have the warning level. This isn't breaking your system, but it might become a problem later. Here we have things like response time for API exceeded, or disk space on server is close to threshold. Then we have the error level. Something broke and needs attention. This is when a function fails, but the system is still running. Some examples are database connection failed, or payment gateway errors. And finally we have fatal level. This means drop everything and fix it now. Some service crashed or something is not working at all. Errors like out of memory, critical errors during startup, and service failed to start. When used the right way, log levels can help you filter through logs efficiently. If you're looking for a bug, you don't want to search through pages of general logs just to find a single error. But what goes into a log? Let's look at this example. It describes the execution of the event, but it doesn't provide enough details when you are debugging. Now what do you think of this log? It answers the 4 basic questions that it should. Who, why, when, and where. With this information, you have everything you need to build your story. Most logs should contain relevant metadata to provide context. Useful metadata includes a timestamp, hostname or IP address, user ID, request ID or trace ID, service name, and stack trace. This can change based on your event's role and scope, but it's a good starting point. What metadata do you include in your logs? Let me know in the comments below. And while you do that, don't forget to hit the like and subscribe button. And talking about trace IDs, in a microservice architecture, tracking a single request across multiple services can be time-consuming. That's why I recommend including a trace ID in your logs. Here's how it works. You generate a unique ID at the request entry point, you propagate the ID across services through your communication protocol, and you include the ID in all log entries. Now you can easily track request flows across services with just one filter. Now that we know what to include in a log, we should discuss what not to include. In 2018, Twitter recommended every user to change their password after the company discovered a bug that left unencrypted passwords in an internal log. So the best way to prevent security risk is to not log sensitive information at all. This includes data like personal information, passwords, API keys, or basically anything that an attacker might want. But if you really need to log sensitive data, make sure you mask or redact it like in the example below. You can use logging libraries that support automated masking. And while this log is readable, it would be quite difficult to parse it in an automated way. This is where structured logging comes in. Structured logging uses a consistent, easy-to-parse format such as JSON, making it easier to process logs with automated tools. Tools like Elasticsearch, Splunk, or Grafana can process structured logs, turning them into visual dashboards that make debugging much easier. Now you can easily sort logs by user, event type, or error. Even more, you can use these tools for monitoring and alerting because logs shouldn't just sit in a file. They should trigger alerts when something goes wrong. You can use log monitoring tools to detect patterns of warnings and errors, trigger alerts for critical events, and to track system health over time. And regarding system health, while logs tell you everything about your code, they also consume memory. The bigger the project, the more space your logs will take. That's why you need log rotation and retention policies. Rotate your logs based on size or time, like weekly or monthly, or when they exceed 10 gigabytes. Compress old logs to save space, and define retention policies based on compliance and operational needs. For example, you can retain your debug logs for a month and your audit logs for a year. And now that we understand how powerful effective logging can be, it's time to think about the bigger picture. Good logs are only as useful as the code that's generating them. If your code is messy, your brain will have a hard time understanding and debugging. The way you structure your code directly impacts how easily you can maintain it, debug it, and yes, plug it effectively. So watch this video next to see how bad code can make debugging harder and how to write clean code instead.